Okay, so we want to find the inverse Laplace transformation of this one. Now when we look at this, we are clueless. We can't say what is the inverse Laplace transformation because we are not familiar with uh, this kind of expression. So what we will try to do, we will first try to expand this in terms of partial fraction, and then we will see if we can get anything familiar of which one's inverse Laplace transformation we know. So let's do partial fraction expansion. So it goes like this: s plus 4 s square plus 5, so a s plus 4 plus bs plus c s square plus 5. Now we will multiply both sides by this thing. So on the left hand side we have s minus 2, on the right hand side we have a s square plus 5 plus bs plus c s minus 2. So it becomes s minus 2, it becomes plus s plus 4, bs plus c times s plus 4. Yep. So it is s minus 2 on the left hand side, on the right hand side it is a s square, we are getting rid of the brackets, plus 5a plus bs square plus 4bs, bs square plus 4bs plus cs plus 4c. So we can write this like this: a plus b s square plus 4b plus c times s plus 5a plus 4c. Now first we will equate the coefficients of s square on both sides. So on the left hand side there is no s square, so the coefficient is 0, and on the right hand side it's a plus b. So from here we get a is equal to minus b. Then we will equate the coefficient of s on the left hand side and on the right hand side. On the left hand side the coefficient of s is 1 because it's just s. On the right hand side it's 4b plus c, 4b plus c. So that's there. Let's call it equation 1. Then we will equate the constants. So on the left hand side it's 2a, on the right hand side is 5a plus 4c, 5a plus 4c. So let's call it equation 2. Now we know a is equal to minus b. So what we will do, we will multiply equation 1 by 4 and then we will add with equation 2. So 1 becomes 4 here, 16b plus 4c, and this stays the same, minus 2, and this is 5a. 5a can be written, I will write in terms of b, so that will be minus 5b and then plus 4c. So we actually have to subtract because we want to get rid of c, so we will subtract. Okay, so this is becoming, this is minus, this is plus, and then this is plus as well, so that's 21b equals to 6 here. So b is 6 over 21, which is 3 over 7. So a is minus 3 over 7, and what's c? C we will have 1 minus, we can say 1 from here, 1 minus 4b. So that's 1 minus 12, 7, 12 over 7. Actually this one is 2 over 7, not 3 over 7, 2 over 7 as well. So that one becomes 8. So that is minus 7 plus 7 minus 8 over 7, so that's minus 1/7. So a is minus 2 over 7, b is 2 over 7 and c is minus 1 over 7. So the right hand side becomes, it was a over s plus 4, so that will be minus 2 over 7 s plus 4 plus we will write bs. Bs is 2s over 7 and that's s square plus 5. So I will write this separately, so that will be, I will write bs over x square plus 5 plus c over s square plus 5. So c is negative 1 over 7 s square plus 5. When we look at this one, we know this is just the coefficient. So if we want to find the inverse Laplace transformation, we can do it now, because now we can tell what is the inverse Laplace transformation of that one. So that one becomes minus 2 over 7 e to the power minus 4t, because that is s minus a when it's e to the power at. The Laplace transformation of e to the power at is 1 over s minus a. Since this is plus, it becomes minus 4t. So that's there. Now for this one, if we recall, s over s square plus 5 or s over s square plus square root of 5 square, this is Laplace transformation of cos square root 5t. This is the coefficient of t. So 2 over 7 cosine square root 5t, that will be the inverse Laplace transformation of that one. And finally 1 over 7. But when we look at this one, there's a 1 there. So if we recall the Laplace transformation of sine of at, that one is s square plus a square, on top it's a. Now we have here, we can write it s square plus square root of 5, but it has to have a square root on top, as square root of 5 on top as well. So we can multiply this one here, we can write the square root of 5 so that it gets cancelled out. So basically this one we can write square root of 5 s square plus square root of 5 square. Then the inverse Laplace transformation will become sine square root of 5 times t. So I could have written one more line so that I could have I should have probably rearranged it, but I have just written directly. So yeah, I won't leave it here. What I will do, just forget that, minus 2 over 7 e to the power minus 4t, then plus 2 over 7 cosine square root of 5t, and then this one is again minus square root of 5, and then this one is becoming, so what I'm doing, I'm multiplying numerator. I want to get rid of the square root in the denominator, so I'm multiplying for this one. I'm multiplying both numerator and denominator by square root of 5 for this part basically. So it's becoming square root of 5 and then 35. 7 times 5 because square root of 5 times square root of 5 is 5. So that's sine square root of 5t. So this is the inverse Laplace transform form of the given one, which was of course this one, s minus 2 is I don't know, is what I forgot. S plus 4 times s square plus 5. So s plus 4 here and s square plus 5. So this is how we have to rearrange. We have to do partial fraction expansion often, so that we can find something that's familiar to us. So we know that when we get something like this, we know the inverse Laplace transform e to the power minus at and so on. So yeah, this is why it's in the previous video I did write down some of the more common ones, the Laplace transformation, because it's helpful to memorize those common ones, the ones we encounter more often, so that we can readily, when we arrive to something familiar, we can readily find the inverse Laplace. Otherwise we will have to always look up the table, and which is not very convenient. So we should try to memorize few of the common ones.